Hi Kokom, good to see you, man. I heard you were doing a hypothesis test. What is that all about? My professor asked me to run a test to see if his prep course that he runs for the ACT is worth the money. You see, the average grade on the ACT is a 20. So he wanted to run a test to see if his class helped kids to get higher scores. Oh, I see. That sounds interesting. Were your results significant? Well, that depends. Do you mean statistically or practically significant? I guess I don't know. Aren't they the same thing? Oh no. No, they were not. Then what's the difference? Well, you see, when you do a hypothesis test, we are looking to see if the results are statistically significant. And how do you know if they are statistically significant? We can tell by the p-value. A p-value? What is that? A p-value is the chance that we would get a result as extreme as the null hypothesis just by chance. If we were to collect the data again, do you want a big p-value? No. Of course not. If there is a big p-value, we cannot reject the null hypothesis. If the p-value is small, on the other hand, we can reject our null hypothesis. So small like 2? No, 2 is much too big. Most of the time, for the test to show statistical significance, the p-value needs to be smaller than 0.05. So how does this relate to your study? Well, in this study, we want to see if my professor's class helped kids to get higher scores on their ACT. Therefore, our null hypothesis would be that the mean scores of students that took his class is equal to 20, and our alternate hypothesis would be that the mean scores of students that took his class is greater than 20. So you're saying that if the p-value from this hypothesis test is very small, that there is statistical significance that the students that took the class had a better mean ACT score? Correct. We could reject our null hypothesis and say that we are 95% confident. And so what about the practical significance? Where does that come into play? Oh, you see, sometimes we get results that things are statistically significant, when in real life, they probably do not make sense. What do you mean? How could that happen? Didn't you already prove it was significant? Statistically, yes. However, there can be outside factors that complicate the results. For example, the larger a sample population gets, it becomes more and more normally distributed. As it keeps getting larger, the standard deviations become smaller. So if the sample population is normally distributed just because it is so large, we might get results that are statistically significant, even when they don't make sense in the real world. So how would this relate to the ACT class? Well, you see, this class cost $500. So we might get statistically significant results that students typically score higher after taking the class. But if they only score a point or two higher than the average student who doesn't take the class, it is not practical to take the class. It wouldn't be practically significant. Oh, I see. Are there ever situations when something is practically significant, but not statistically significant? No. Never. If there is no statistical significance, we don't even need to worry about practical significance. Oh wow. Okay. Thank you so much. I learned a lot today.